Before we can look at the refrigerants used in split systems, there are a number of terms that you need to familiarize yourself with as a split system installer. The common groups of refrigerants can be classified according to their chemical composition. A CFC is a fully halogenated, no hydrogen remaining halocarbon containing chlorine, fluorine, and carbon. A HCFC is a halocarbon containing hydrogen, chlorine, fluorine, and carbon. R22 is an example of a HCFC. A HFC is a halocarbon containing only hydrogen, fluorine, and carbon. R410A and R32 are examples of HFCs. A HC is a hydrocarbon containing only hydrogen and carbon, such as R290 and R600A. A natural refrigerant is carbon dioxide, CO2 or R744, and ammonia, R717. The manufacture of CFCs and HCFCs has been phased out and replaced with products such as R410A by the Montreal Protocol because they contribute to ozone depletion in the upper atmosphere. Azeotrope refrigerants are a blend of two or more single component refrigerants that act as a single fluid. Azeotrope refrigerants boil and condense at one temperature for a given pressure. The components of azeotropic mixtures will not separate under normal operating conditions and can be charged into a system as a vapor or a liquid. Only one column is needed to show the pressure-temperature relationship for any phase change process in a system. Zeotrope refrigerants are also like azeotropes, as they are a blend of two more single-component refrigerants. These zeotrope blended refrigerants boil and condense at a range of temperatures for a given pressure. Therefore, zeotropic blends cannot be defined by a single pressure-temperature relationship. The temperature glide will cause different values for temperature for each refrigerant at a given pressure. Zeotropic mixtures should be charged into a split system in the liquid state. R410A is an example of this. It is made up of 50% HFC32 and 50% HFC125, which have different boiling and condensing points. Charging additional refrigerant into split systems. Azeotrope types of refrigerants, such as R22, can be either liquid or vapor charged into a split system. Zeotrope type refrigerants, such as R410A, must be liquid charged into a split system. If R410A split systems are vapor charged, the two refrigerants may separate, leaving you with a useless refrigerant. R32 can be either liquid or vapor charged into a split system. Temperature glide. As the refrigerant moves through the evaporator or condenser, each refrigerant in the blend will boil or condense at its own saturation temperature. The two blended refrigerants in R410A will boil at different temperatures at a constant pressure. At constant pressure, the difference between the saturated vapor temperature and the saturated liquid temperature is referred to as the temperature glide of the refrigerant. Temperature glide is found in zeotrope refrigerants in the R410 series, such as R407C and R410A. To summarize, a blend is a mixture of refrigerants. An azeotrope is two or more refrigerants mixed together that will only have one boiling and/or condensing point for each system pressure. A zeotrope is two or more refrigerants mixed together that will have a range of boiling and/or condensing points for each system pressure. Glide is the difference between the boiling and condensing points of the refrigerant.